So now we're in a good position to finally define this notion of NP-completeness that I mentioned in the beginning of the unit. We can say some problem X is NP-complete if it satisfies two properties. First, it has to be NP-hard, meaning that nothing in the set NP is harder than X, which is to say that if you could solve X in polynomial time, you could use it to solve everything in NP in polynomial time. And the second important property is that X itself is in NP. So it's in the set, and it's as hard as anything in the set. So it is, in fact, the hardest in the set. And though it may seem a little weird to satisfy both of these at the same time, there's actually tons of problems known to be NP-complete. Very often when you go to solve to develop some kind of algorithm for solving a problem, and it just doesn't feel like there's any way to get a foothold on it, it's a good idea to check. Is it NP-hard, and is it in NP? If so, it's NP-complete. And at this point now, tons of problems are known to be NP-complete. There's lists, there's online websites that list lots of problems. There's wonderfully written books that lay out problem after problem after problem. And sometimes they're really natural extensions of each other, and sometimes it's really quite interesting to see how they're connected to each other. Saying that some problem is NP-complete tells us an awful lot about that problem. So let's imagine that there's some problem called graph partitioning, which is a real problem, and it is related to social networks. But I'm not going to tell you what it is. But I will tell you that it's NP-complete. Now, even though you don't know what it is, there are some things that you do know by virtue of the fact that it's NP-complete. Assuming you believe me, you'd know the following things. So which of these, check all that apply, which ones do you know? If I tell you that graph partitioning is NP-complete, does that mean it's NP-hard, and therefore that a polynomial time solution for that problem solves everything in NP? Do we know that the problem clique can be reduced to it, given what we've said so far in this unit about clique? Do we know that graph partitioning is in NP, and therefore that an exponential time solution would exist? Do we also know, or do we know that it can be reduced to SAT, based on the things I've told you about SAT in this unit? So check all that apply.